Hello and welcome back to Thailand. It's a beautiful sunny day in mid-November as the cooler, drier season starts and high season is starting for the tourists. Although they haven't shown up yet, so I'm wondering what's going to happen with the economy. But I apologize for not putting out a video in quite a long time, but I'm actually just back to Thailand myself because I got a message from my dad that he was going into hospice care. So I immediately jumped on a plane and went to where he lives, and my sister flew down, and we were with him for a week until he passed away. And then I stayed on for about another month and a half to take care of his estate. But I'm back now, and I thought I would show you a little bit of something that I've been working on. Now, you may have heard about different home automation systems with Alexa, and you can turn it on and tell it to do things, and sometimes they can remotely control things like light switches. So you can say, the lady's, I don't want to trigger your own device in your house. So I'm going to say, lady's name, turn on the bedroom light, and then bing, the light goes on, right? But there's a lot of magic that happens under the covers to make that happen. There's a lot of hardware and there's a lot of software. And I thought, I don't want to take the easy way out. I want to do it the hard way and actually try to understand the hardware and the software and kind of build up my own customized system that will let me start at the basics and then I can move forward in the future. So I'll show you what I'm working on. So this little box over here is a device from a company called Sonoff, and this is their simplest device in the family. It is simply an on-off switch, and there's a little black button, and you push it, and your device goes on, and your device goes off. Now, the cool thing about this is the circuit board that is inside here is hackable. And there's an open source project called TezMota, and don't worry, I'll provide links to everything. You can actually update the firmware that's running on the circuit board inside here to be running the TezMota system. Now, this is generally called an ESP8266 based system, where there's a little microprocessor. It has hardware control that it can turn the circuit on and off that's passing through it, and it's also connected to your Wi-Fi system. So having a little button here that turns the light on and off isn't really that useful, but you can actually turn it on and off through an app. Okay, so here I've got an app called TezMota Control. There are a lot of them on the open market that you can download and install. So I'll launch it. And I've pre-configured my devices. I have a bedside lamp and I have another device that I'll talk about in a minute. And you can set them up through the configuration page. You can look at your devices, you tell it what kind of device it is, and you can tell it its configuration, where it lives on your Wi-Fi network, ports, usernames, all that kind of stuff. But once you've got it all configured, you can come all the way back out, go into your device, and you can turn it on and off. And it's hard to show, but I'll let you listen to see if you can hear that switch clicking. Off, on. So I can remotely control that light from wherever I have access to my Wi-Fi network. Now, there are other apps that you can set up which will let you do the same kind of functionality wherever you are on the planet using a slightly different technology mode. So let's dive into things a little deeper. Now, the other device you saw running in that app is this one. It's a different device from the Sonoff family called a power meter, or a POWR2 device. Now, this also has the on-off button on it, and I've got it wired into that 20-watt LED light right there. So I'll click it, off, on, and I can do that from here. I can also control it from that app. So let's take a look and see how that works. Okay, we're back in the TezMota app now, and you can see the second device right here. I've labeled it solar power meter because the POW R2 device is not only a switch, but it measures the power that's flowing through it. So you can see that 20 watt LED light I have is actually drawing 20 watts as advertised on the sticker. And it gives me information like watts, amps, and volts, how much energy it has used today, how much energy it used yesterday, total energy. And the really cool thing is I can remotely collect that information and do useful things with it. Okay, I'm going to back up a little bit and explain this TezMota thing a little bit. TezMota, as I said, it's an alternative firmware for a device that's based on this ESP8266 microprocessor board. So it's much more powerful than the firmware that comes on the standard Sonoff board out of the box. And as you can see, this is the web page for that bedside lamp switch, and I can turn it on and off here through a web interface. We'll see if we can hear the click. So it just went on and off, but I can go in here and configure the heck out of this thing. I can say what type of device it is. These are all the Sonoff devices that are supported, and you can do tremendous things with all of these different devices on the market. You can specifically set the function of the I/O pins on the board, although by default none of them are used. I can go back, I can say the connection for my Wi-Fi and the password and how I want to name it on my network. And all these things. You can set up the device so it will automatically do things on a timer basis. You can turn logging on and off, which is really quite useful when you're first trying to get your device to talk to the network. So you can see if you've got network connection issues, if you have permissions issues, things like that. And then here's the one for the POW R2 module, so I can turn it on and off. But since it knows that this is a POW R2 device, it's automatically, let me get back to the main menu. It's showing me all the things that this box is reading. It's reading voltage and current and therefore power, but it also records historical energy use. Now, this is the key to what I really, really want to do in the end. I want to put a solar module out of my balcony and use this device to record how much energy is being produced. I'm building my own little solar monitoring system. Now, this is what I did at my house in California. This is what I did for 5 years as the solar monitoring engineer for REC Solar, which is now called Sunrun. That was my job. But here in Thailand, I want to make a little bit of solar power and then collect the data and draw charts and graphs. And right now, this is measuring the consumption of that LED light, but soon it will be measuring the generation of electricity through solar, and the numbers are just going to be negative. It's going to be showing minus 0 point something amps. Okay, now that you understand the hardware and what I want to do with it, let's talk about how the magic happens. Now, in the world of devices, this is what's called Internet of Things. There's going to be a bajillion little smart devices hanging off internet network connections around the planet, and you'll be able to do new and interesting things with them. One of the ways that you get your devices to communicate with each other that's popping up in popularity is this thing called MQTT. MQTT is a software protocol in what we in computer science call publish and subscribe. Now, if you were to subscribe to your local town newspaper, you let them know, you say, I want to subscribe to your newspaper, here's my payment each month. The newspaper then publishes the newspaper to you. They either throw a bunch of dead trees onto your porch every morning, or you get to read the articles electronically. So you can see there's a correlation here with this whole notion of publish and subscribe. So you have all your devices which publish their information, and a central server at which you subscribe for both push and notification. Okay, so these Sonoff devices publish their information, and anything else in the world can subscribe to their notifications. So all you need is an MQTT server somewhere on the planet that waits for the Sonoff device to wake up and publish itself and log into the MQTT server, and that acts as the message dispatch. You might have another piece of software that subscribes to a notification that's coming from a Sonoff device. Like, I can get notification that my bedside light went on and off, and I can get notification every time the POWR2 device publishes current and voltage and power readings. Now, I've got that configured to do it every 5 minutes, which is beautiful. Now, the publish and subscribe protocol uses what's called a topic. Now, here's where it gets weird. The syntax is ugly, but it works, and you just have to not argue too much against it. What you do in your MQTT or your Internet of Things device, your Sonoff device, is you define a topic. Well, I can't drag that, but you've got a topic, and then you've got this thing called full topic, which has a prefix and then the topic. But you don't really have to worry about that too much. Once you've got it working, it just works. Basically, you want your topic to be understandable by you as the kind of data that's flowing through your system. Now, the Sonoff device needs to know where to send the information. So you set that up through here. You put your host name, which is your MQTT server. The port is standard, port 1883. You can set up a user and a password if you want to protect your information. And then this is the data that flows in topic format. Now, if I come over to my bedside light configuration, I can go into the Configure MQTT section and say, here's my host, which is my rented server, which is located in Singapore, standard port 1883. The client ID is not really relevant. My user ID, and it has a password. Now, here's my topic, Sonoff Basic 1. This is the name I've given to the data that flows from that bedside light, or the commands that are sent to that bedside light. And this topic business, you just, in fact, you need to reverse this. This is topic and prefix, which is a little strange. Again, the syntax is horrible, but you just get to live with it. Okay, here's a simplified diagram of what we've got so far. We've got two Sonoff devices, which are configured for MQTT, publish and subscribe, and they both log into a Mosquitto server on my Linux server in Singapore. Mosquitto is an open source MQTT server implementation. You can download it for free, you can install it, you can configure it on many different software hosts. I've got it running on my Linux box in Singapore. So, anytime anything happens, these two devices will publish that information to Mosquitto, and it manages the state internally. But the cool thing is also, anytime anything happens, there can be triggers and things that happen based on that. So let me draw the next box. Okay, we now have more boxes and lines and arrows. So what have I done? I brought a web browser into it because the web browser can connect to the Sonoff devices and perform the local configuration, as we've seen. But the web browser can also talk to a web server running on my server in Singapore, and I'm using the very popular Apache web server. And you can put your own personal website in there, and it can be a gateway to many, many interesting things that happen inside the server, because every piece of software you install inside a server today can normally be configured via a web interface. So the next step, the one I want to talk about, is a control and triggers of what happens to the information that gets published and subscribed to inside the Mosquitto server. And that's something called NodeRED. This actually comes from IBM. They've donated it to the open source community. And it is a visual scripting event system. Is maybe a terrible way to describe it, but it does the job for things that we want to do because it understands MQTT things. And we log into it through a web browser, through Apache, and into the NodeRED configuration screen. So let me pop over and show you how that works. Okay, here we are inside the NodeRED development environment, if you want to call it that. And you can see it's got a lot of these little nodes on the side, and each node does something for you. These are all things that deal with input. You can inject a text string. You can check for status. It does MQTT things, which we're going to need. It does web servers. It does sockets. It does raw networking. You can do things with outputs. And then it has functional nodes, which are delays and triggers and kind of visual programming things, if then else, split, join. It knows JSON syntax, it knows XML, it can tweet, it can do file handling, and all kinds of things. But the way I've got this set up is it controls the bedside light switch. And you can see I've got two input nodes, one's called on, one's called off. And if we look at it, the payload for the on switch is the string ON. And if I click that, it's going to inject the string ON into this thing, which is an MQTT output node. So whatever comes in here goes to a server somewhere in the world, which I've defined mine, DigitalOcean, and it understands the IP address, the password, the user ID, and all that is configured in here. Then here's where we get to that topic business. So remember I called mine Sonoff Basic 1. So that's the start of the topic. Then I want to send it a command, and the command sub-command is called power1, and I want to send the text string ON to this topic. Now because this device is sitting listening for this topic, it has subscribed to this topic. Anytime this gets triggered, it will go to this server, and then things happen. So if I come here, now if I click on again, I'm doing screen capture so you can't see it, but you might be able to hear it. Okay, we just turned the light on. We just turned the light off. So we can do that through NodeRED in real time. Now, this thing over here is another MQTT, but it's an input node, and it sits waiting for a status command called result that will be sent by that Sonoff box. This server catches that and sends it out to an output node, and it's displaying the value of the payload. Now those displayed values come out here, and we saw that the payload string for the first one was powered on and then power off. So here I'm clicking a command, it goes through NodeRED into the Mosquitto server, up to the light, and turns it on. The light then sends a status message back down to the Mosquitto server, and NodeRED has subscribed to the status value, which it then displays. So we have full round-trip command and response via the publish and subscribe model that Mosquitto and NodeRED are working with. And that's great. But that's child's play, you say. Show me something more complicated. All right, get ready. Now, this is the section that I've designed that controls the Sonoff POW R2 device. It has two separate things it can do. I can turn it on and off to the Sonoff POW1 device on my network. I can turn it on and off, and we capture the response in the payload. So I can click on, and we got the on response back. I can click off, and we got the off response. And I'm going to put the microphone right next to the switch. On, off. So we're controlling it exactly the same way. But the cool thing is that it is now also set up to read the power data. Now I've configured the power switch to send out a burst of data every 5 minutes with the volts and current and power readings. And that is defined by this topic, which is magic. And then that gets displayed here in the payroll over here. The payload, sorry, gets displayed here. And you can see right here, here's one. Wow. Sorry. It timestamps it. And it has, there's the power factor, voltage, and current. So the light switch was off when that happened. But if the light switch happens to be on, the next time 5 minutes rolls around, we will display that here. Now let's clean that up. Another thing I do, and this is really where it comes into effect for capturing my solar power data, is the when that string comes in with all of those values embedded in it, I then convert the JSON format, Java string object notation, I convert that into just a standard string object. I then, from that, I extract voltage, current, and power. And I do that by reading different subnodes of the payload. So payload energy voltage, I turn that into a local variable called voltage. Current gets copied into a local variable called current. Now, what do I do with that? I write it to a database through this command. I actually generate an SQL statement that inserts in the proper format the voltage, current, and power. That gets inserted into an SQL database with another node down here. It goes into my database that is on that same server in Singapore through the user ID and password that I define, and then everything shows up in my database. Now we have more boxes again, and I've added a MySQL server and a database inside with all of my solar data. Now, there's a very useful tool called PHP MyAdmin that lets you graphically, through a web browser, administer your MySQL database. So what we're seeing is when I'm clicking around inside NodeRED, I can write a script that causes NodeRED to write things to the MySQL server which end up in the database table. And I can set up the database through PHP MyAdmin, and I can look at the data as it's being stored, and I can make sure that everything looks good there. Now we're inside PHP MyAdmin, and you can see I have a table, columns of time, voltage, current, and power. So every 5 minutes, the Sonoff POW R2 device is going to publish its power data to the Mosquitto server, which is caught by NodeRED, goes through my script, extracts the values, and inserts them into this database. And you can see we had some values here where the light was on, and then the last 3 5-minute samples the light has been off. And this helps me validate that everything is working correctly. Now that takes me to the last step. And this is the ultimate step in the path of all of that software and all of those network data transfers. My web page showing my solar power, or my theoretical solar power, once I have the system set up. This is not my condo. This is an example of somebody who's gone quite nuts with solar on their condo. I will update this with a picture of mine when it's installed, and I will have a single module driving a single microinverter. Now, what happens is this little embedded section of the page right here is a combination of PHP and JavaScript that reads data from the database and formats it using the Google Charts object API. So this is a Google Charts gauge. It's highly configurable. You can set your starting and ending values, you can set your colors, and basically this page refreshes every 5 minutes, and it will show the instantaneous power being generated by the solar. It's off right now. I'm going to turn the switch on manually. Maybe we'll catch the next 5-minute update. The next chart is called an area chart, and it shows the amount of solar power being generated. It's basically the area under the curve. So I turned the light on around 9:43, and it went off around 2:29, and we've had 3 of those samples in the database at 0 values, so that's why we're showing that. I show the raw amount of power being generated, and then I calculate the energy for the day. 96.42 watt hours have been generated the area under the curve. And that's for today. Then I do the last 7 days as a bar chart. I can look back in the database and extract those values, and then I do lifetime. And as many columns as the Google chart will hold, I'll do that. I may have to change this if I have several hundred or several thousand values in here. I don't know how that's going to affect the Google chart. And then again, I calculate total solar energy lifetime in kilowatt hours. And this is, of course, all sample data. But this is the end goal of me designing my new, yet another, solar power monitoring system. I'll show you the one I did for my house in California. It was actually a Java application that ran inside a web page using the JNLP web start technology, which is now obsolete. Java does not support that anymore, but this would basically show real time. I had the same kind of graph. I had all the DC values, AC values today, lifetime. I even pulled weather data from a website and packaged it up here. Then I had a very highly customizable graphing system down here that showed AC and DC as the direct output of the inverter in my system. But of course that system has been dismantled. I sold it before I left California. And I am now here with a new, there we go. We tripped our 5 minutes, and there we are. We are back up running again, and we got a 19 watt sample right there. If I can hover over it, sometimes the hover doesn't work very well. There it is. So we are now making power again. Okay, here's the web page that has all of the data handling and display. It's 293 lines of coal blue twisted steel. It includes a section of PHP code that you can see here, and then standard HTML section starts, and then there's a JavaScript section which actually talks to the Google Charts controls, and then this is all the display stuff. Everything's broken down in these divs in order to put boxes around things and organize them on the screen. So the PHP is mainly for database access. So the first thing we do is we connect with the database, and I'm using the MySQL style queries, and these are built into PHP. It knows how to directly query a MySQL database, so it's very convenient. So there are 4 sections, and I've broken them up this way. This one does the instantaneous power reading. So there's an SQL section, select power from the solar power table, order by time, descending limit 1. So what this does is it gives me one power value back in the very last row inserted into the database, which is the last power value measured. I execute that query, I fetch the data into an array, I pull the power value out of the row, and that value is now ready for use down below. And then there are several sections for that. Here's the one that pulls all the value for today, and this involves a loop where I go through and I pull the last 7 values as defined by this more complicated SQL statement, and I only pull the values from 7 a.m. to 7 p.m. There's no point cluttering the table with values that are always going to be 0 when the sun's down. This is all for today. The next block is the last 7 days with this query, and it uses the interval part of the SQL statement, and then this selects every item in the array with an even more complicated SQL statement. So, by the time this is done, I've extracted all the data I need. Now I have 4 different Google charts: instant, today, last 7, and lifetime. And each one of these functions draws a chart. And first thing you have to do is take the data that you pulled, which is represented in this value, and I pull the value of that by wrapping it in a PHP statement, and I convert that data into the format that Google requires with some options for the way the chart looks. I create a gauge, and then I draw the gauge with that data. And I do that for instantaneous power, today's power, the last 7 days power, and lifetime power. There's some CSS here that works around a problem with the Google gauge where it doesn't center itself properly, so you have to do some CSS fiddling. And then the rest of these is just a div for each section, defines the width, makes an outset box with 5 pixels wide. This is all look and feel stuff. So that's a very quick look at the code that took me many hours to write. So that about wraps it up. I know that was a very whirlwind explanation of how I went from a very simple little white plastic box to showing real-time solar power data on my website. There are other ways to do it, certainly. There are some manufacturers that provide a website. Great. I don't know if the microinverter that I buy will be providing that kind of data, but I'm counting on it. I'm not counting on that application. I'll probably just buy a Chinese one that doesn't have any data output. But it's also been kind of a fun programming exercise. I learned a lot about how all this stuff works. Now, I need a vote from you, my oh-so-smart viewers. Do you want me to go more in-depth about any aspect of this? I'll bring up that picture again. Any aspect of this, understanding the TezMota, how to flash the firmware is a very interesting technology exercise into itself, how to configure it, how to set up, install and set up Mosquitto on Linux, Apache, pretty much everybody can do that, how to set up and write scripts for NodeRED. MySQL is not that difficult. PHP MyAdmin, this is also a very well-known and well-understood aspect of the system. So it's basically the Sonoff firmware, configuration, Mosquitto, and NodeRED are the interesting things. Oh, and also the web page with the PHP and JavaScript that actually query the database and reformat it and show the graphs and the Google charts. So anything in there that you want me to do a video in, I can easily whip off a 10 or 15 or 20-minute video on any aspect of any of these things. I learned a lot from watching other people's videos and web pages. I did 1,007 Google searches in the course of doing this project. So I just want to help spread the knowledge. So just type down in the little comment doodly-doo and see if you want me to do any of that. But otherwise, thanks for your patience while I was away, and happy MQTTing. Welcome, people who stayed to the end of this exciting video. I just want to let you know I've had a bit of an epiphany about YouTube, and it makes me sad. I've been asking people to subscribe to my channel and click the like button in the hopes that YouTube would recognize my channel and kick in a little ad revenue for all these goodies that I'm buying to help me with my little projects. And I realize it's all in vain. YouTube is caring less and less about the people who use its channel. Even the big boys and the big girls are having to go to something like Patreon for financial support. And I'm just not worthy of a Patreon following for anybody. So if you've enjoyed my stuff and you want to see more of it, go ahead and click subscribe and like if you like. Otherwise, just enjoy this picture of my beach here in Thailand and enjoy the rest of your day, and I thank you very much.